Hello everyone, welcome back to our channel CS Pictorial. This video gives you sample problems related to canonical and standard SOP and POS forms with simple step-by-step solutions. These type of conversion problems can surely be expected in competitive exams. Watch this video until the end for clear understanding, and each problem is going to be different from the other. Canonical and standard forms of SOP and POS are explained in detail in our previous videos. Kindly check the links given in the description. In the first problem, we are asked to find the expression in POS form from the given truth table and options are given. Since we are asked to find the expression in POS form, pick out the truth table entries for which the output value is 0 and write the corresponding max term. To derive the max term, always remember for POS, if the value of the input variable is 0, write the literal as such in the max term. And if the value of the input variable is 1, the max term will have the complement of the literal. In the first entry, A is 0, B is 0 and C is 1. So the max term is written as A plus B plus C bar. Similarly, we get the next max term A bar plus B bar plus C bar. Finally, we derive the POS expression by multiplying all the max terms. F is equal to A plus B plus C bar into A bar plus B bar plus C bar. Thereby, the answer for this problem is option 2, A plus B plus C bar into A bar plus B bar plus C bar. This problem looks complicated at first, but it's that very simple if you understand the solution. Which of the following expression is the canonical form for the given standard POS? The standard POS expression is given as A plus B bar into B plus C. We are supposed to find the canonical form of this POS expression. If you are still not clear about the canonical and standard forms of SOP and POS expressions, please check our previous videos. This is a standard POS expression. In a standard POS expression, each sum term does not include all the literals. So, first find the total number of literals involved in the expression. Here, in this expression, 3 literals are involved, A, B and C. Now, find the variables absent in each sum term. In the first sum term, C is missing, and in the second sum term, A is missing. Now, add the product of missing variable and its complement to each sum term. The expression is then written as A plus B bar plus C into C bar into A bar plus B plus C. Expand all the terms in the next step. The expression now becomes A plus B bar plus C into A plus B bar plus C bar into A plus B plus C into A bar plus B plus C. There are no recurrent terms here, so this is the final canonical POS expression. The answer for this problem is option 3, A plus B bar plus C into A plus B bar plus C bar into A plus B plus C into A bar plus B plus C. In this problem, we need to find the minterm expansion of a given SOP expression. F of P, Q, R is equal to PQ plus QR bar plus PR bar. The options are given. The solution to this problem involves 2 steps. First, convert the given SOP expression into its canonical form. Then use the truth table to find the corresponding minterms. As the first step, let us convert the given standard SOP expression into its canonical form. In a standard SOP expression, each product term does not include all the literals. So, first find the total number of literals involved in the expression. Here, in this expression, 3 literals are involved, P, Q and R. Now find the variables absent in each product term. In the first product term, R is missing. In the second product term, P is missing. And in the third product term, little q is missing. Now multiply each product term by the sum of its missing variable and its complement. The expression is then written as PQ into R plus R bar plus P bar into Q R bar plus P into Q plus Q bar into R bar. Combine all the terms in the next step. The expression now becomes PQR plus PQR bar plus PQR bar plus P bar QR bar plus PQR bar plus PQ bar R bar. Cancel out the recurrent terms, making the final expression as PQR plus PQR bar plus P bar QR bar plus PQ bar R bar. This is the final canonical SOP expression. Now, with the canonical SOP expression, we use the truth table to find the minterm entries. For the first product term PQR, the input values could be taken as P equal to 1, Q equal to 1 and R equal to 1. So, enter 1 in the corresponding truth table entry. Similarly, for the second product term PQR bar, the input values are P equal to 1, Q equal to 1 and R equal to 0. Make an entry 1 in the corresponding output value F. Again, for the next product term, P bar Q R bar, P equal to 0, Q equal to 1 and R equal to 0. So, enter 1 in the corresponding field. And finally, for the product term P Q bar R bar, the input values are P equal to 1, Q equal to 0 and R equal to 0. Enter 1 as output value for corresponding truth table entry. Now, mark the minterm representations as M0, M1, M2, etc. up to M7. Pick out the minterm entries for which the output value is 1. That becomes the output F equal to M2 plus M4 plus M6 plus M7. Thereby, the answer for this question is option 1, M2 plus M4 plus M6 plus M7. A Boolean function expressed in SOP is given as f equal to a bar b bar c bar plus a bar b c bar plus a b bar c bar. We are supposed to find the product of sums, POS form of the given function. The options to pick out the correct answer are given. This problem is also solved in 2 steps. First, use truth table to find minterm entries and then derive maxterms. Then enter the maxterms in the truth table to find the final POS expression. Since the given SOP expression is in its canonical form, we use truth table to find minterm entries. For the first product term A bar, B bar, C bar, the input values are taken as A equal to 0, B equal to 0 and C equal to 0. So, enter 1 in the corresponding truth table entry. Similarly, for the second product term A bar, B, C bar, the input values are A equal to 0, B equal to 1 and C equal to 0. Make an entry 1 in the corresponding output value F. And finally, for the product term A, B bar, C bar, A equal to 1, B equal to 0 and C equal to 0. So, enter 1 in the corresponding field. Now, mark the minterm representations as M0, M1, M2, M3, etc. up to M7. Pick out the minterm entries for which the output value is 1. That becomes the output F equal to M0 plus M2 plus M4. That is summation M of 0, 2, 4. Here we actually need the max terms as the question is to find the POS expression. Thereby, the terms not present in minterm representation become the max terms. So, F now becomes pi capital M of 1, 3, 5, 6, 7. Since these are the max terms, enter 0 for entries M1, M3, M5, M6 and M7. Write the corresponding max terms. To derive the max terms, always remember for POS, if the value of the input variable is 0, write the literal as such in the max term, and if the value of the input variable is 1, the max term will have the complement of the literal. In the first entry, A is 0, B is 0 and C is 1. So the max term is written as A plus B plus C bar. Similarly, we get all the other max terms. Finally, we derive the POS expression by multiplying all the max terms. F equal to A plus B plus C bar into A plus B bar plus C bar into A bar plus B plus C bar into A bar plus B bar plus C into A bar plus B bar plus C bar. Thereby, the answer for this problem is option 3. Which of the following gives the simplified SOP expression for the Boolean function f equal to m0 plus m2 plus m3 plus m5? This is actually a very simple problem. The given SOP expression can be simplified using a K-map. Since the minterms involved in the expression are up to m5, we understand that the number of variables involved are 3. So we take a 3-variable K-map. And as the options are given in terms of A, B and C, we name the variables in the K-map as A, B and C. First, number out the cells of K-map. Remember, we number the K-map cells in the order 0, 1, 3, 2 and 4, 5, 7 and 6. The reason for this is clearly explained in our previous video about K-maps. Kindly check the link given in the description. Now, place ones in cells 0, 2, 3 and 5 as mentioned in the given expression. Place zeros in all the other cells. The next step is grouping of cells containing ones. A detailed video about K-map grouping rules is already available in our channel. Kindly check the link given in the description. In this pair of ones, C and C bar get cancelled, leaving A bar B in the final expression. In this pair of ones made by wrapping around the K-map, B and B bar get cancelled, leaving A bar C bar in the final expression. And finally, since there is no adjacent ones, we make a group of only one cell containing 1, which gives A, B bar, C in the final expression. Thereby, the final simplified expression is written as F equal to A bar C bar plus A bar B plus A B bar C. The answer for this problem is option 2, A bar C bar plus A bar B plus A B bar C. Okay, then it's done for today. Kindly encourage us by leaving your comments about our videos. Like, share and support our channel. Please do not forget to subscribe to our channel for more such informative videos. Hit the bell icon for sure. Thank you for watching.